Okay, here's a video on slope and graphs. So we're going to go into functions. So it's another term, functions we'll talk about. And we're going to relate events to graphs. Let's just review slope for a minute. So here we have the standard way, well, not the standard way. This is not standard form. This is slope-intercept form. So this is a linear equation. This represents a linear equation in slope-intercept form. We also have standard form, which I'll go over in another video. So here we know a lot from this equation, this way we write it in this form. So if I had, for example, let's say I had that equation, we know it's linear. We know it's linear because there is no exponent in the variable that's higher than 1. So here we know a couple of things. We know that in slope-intercept form, the m is the slope, so we know the slope is 2. That means it's going up by 2 and over 1, up 2 over 1, up 2 over 1. And the y-intercept tells us where the line will cross. So if we did a rough graph, we know the line's crossing at the 6. 1, 2, 3, 4, 5, 6. It's going to cross here, and we know it's positive. It's going up from left to right. So this is just a rough draft. Actually, we want to put arrows on our line. Just a rough draft. So what do we know when we see y equals 2x plus 6? Let's just review that again. We know that the slope is 2. It's going up 2 over 1. We know it crosses at the 6. And we know it's positive. It's a positive line. Okay, so let's just look at a graph here. And let's try to get the equation of this line. Well, we can see it's going through 1. So if we did our slope-intercept form, we have y equals 2x, well, excuse me, y equals mx plus b. That's mx plus b. And we know b already is 1. So we have y equals mx plus 1. That's what we know already. Bring that over so we see it. Now let's look for some points. We did this in another video. Any point you want. We have a 0, 1. We have a 0, 1. Remember, x comes first. The x is 0. The y is 1. We have another point here, 2, 3. And you can use any points you want that are on the line, whatever you choose to use. Okay? And remember, we went over this in class. The slope, if we want to find what the slope is, we're going to use the change of y, this delta symbol, delta y over delta x. And that just means the change of y over the change of x. It's the rise over the run, if you remember. And we also have an equation for that. We're going to take a y minus a y and an x minus an x. And it looks fancy, so let's bring that over a little bit. We have these subscripts. And all we're saying is we have 1y minus 1y and 1x minus 1x. So let's bring that up. Remember, our points are 0, 1, 2, 3. Remember, we have 0, 1 and 2, 3. So we can say m, the change of y over the change of x, the rise over the run. We can say 3 minus 1 over 2 minus 0. If you wanted to do that, 3 minus 1, 2 minus 0. You could have also did 1 minus 3 and 0 minus 2. Don't mix the pairs, though. So we would have 2 over 2, and the slope is 1. Let's go back here. The slope is 1. That means that it's going up 1, over 1, up 1, over 1, up 1, over 1 each time. So our equation then is y equals, since the slope is 1, we don't have to put a 1, because 1 times x is x. And there's our equation. There's our linear equation. So whatever point is on this line, you can use. Whatever points are on the line, you can use. And we know it's positive. It's going up from left to right. If it was going down from left to right, it would be negative. So in this video, we wanted to go over slope. We also want to look at different types of graphs. So here's a type of graph here. Okay, can you see that? I think it was a little blurry. So this is a step graph. It's also called a staircase function. It's a function. Here we're going to talk about functions. And let me just go over this, if you can see it. So this here is the age of the athletes. We have an age from 7 to 17. And these are the times. that they're going to be running or doing their event, whatever the event is. We don't know what the event is. We don't even care. So if you see a solid line, that means we're including that age. If you see a line that's open, like you see here, that means that age is not included. So from the ages of 7 up to 9, they're racing at 8 a.m. That says 8 a.m. there. But we're not including the age 9 because it's not filled in. The age 9, if you see, is the next step up. They're racing at 9 a.m. So if you look at this graph, who's racing at 11 a.m.? Well, at 11 a.m. we have 13-year-olds racing, or whatever their event is, 14-year-olds, and anyone up until they're 15. So if you were 15, you wouldn't race at 11, you would race at 12. So this is called a step graph or a staircase function. And we'll talk a lot about this when we get into more functions in another video. Just right now, make sure you understand how the step function works. So let's see, who's racing at 10 a.m.? Who's racing at 10 a.m.? So at 10 a.m. we have 11-year-olds racing. It's filled in. So anyone from 11 all the way, 12-year-olds are racing, and if you're 11 and a half, you're racing, and 12 and a half, you're racing. But if you turn 13 on that day, then you're not racing at 10 a.m., you're racing at 11. Okay, so that's a step graph. So here we have a function, and here we have the time on the bottom. The x is the time, and the y is the distance. So here we are, and when you see a line going up here, that means we're moving in time. We're moving in time. So we went from 10 minutes, and here it's 11 and a half minutes. So from 10 minutes to 11 and a half minutes, we went from 0 to 30 kilometers. Okay, we're probably in a car. We're going pretty fast. From 10 minutes to 11 and a half minutes, we moved up. Then, as you can see, time stops, because from 11 and a half minutes, well, this could be hours, or minutes, or seconds, we don't know what it is, but from an 11 and a half to 12, time was moving, but we did not, distance stopped. Time moved, distance stopped. So if time moved and distance stopped, that means that if we drove our car, we stopped for either half an hour or half a minute, whatever the case may be. And then we started moving again. So as you can see with these, we can show events. Moving, stopping, moving. So let's look at one. See, we're walking in the neighborhood. Time is the x, distance is the y. So from time 0, we just started. Maybe let's say this is our house. This is the house. And it seems like we're moving pretty quickly because we don't have a straight line. We have an exponential line here. So we're moving pretty quickly. Then we stopped. So this, you would explain this on a quiz that you stopped for a while, and then you started moving at a constant rate. When you have a constant rate, it's linear. Here we were going pretty quickly. We stopped at a constant rate. Then what do we do here? Looks like we stopped again. Now if we're going down, this is negative now. Now we're going back home. We're going back home. We stopped for a while, and then we quickly went back home. So that's how you would explain that type of graph. So let's see if you understand that. Here we have time and distance. You never want to have distance here and time here for this type of graph, because it wouldn't make sense. Let's say this was time, the y was time, and this was distance. That means that you're moving in time, and now you're saying as you're moving, but time's staying still. It's impossible. Right? So let's have this as time, which is the x. What is that there? And this is the y, the distance. So again, you left home, you're moving, you stayed put, you went back home, but then decided to stop for a minute. Maybe you stopped at a friend's. And instead of going back home, you changed your mind. You went somewhere else. Maybe you went to the deli, stayed for a while, and then went home. So that's how you would have to explain it on a quiz. One more thing, just to make sure you know what we know what a positive line is, and make sure you know what a negative line is. Remember, from left to right, it's going down. This is negative. Just looking at this very quickly, though, you can see that the line will cross at the 3. 1, 2, 3. So we know from just looking at this equation, we could say y equals mx plus 3, but we also know that the slope is negative. So we would say y equals negative mx plus 3. Slope is negative because it's going down from left to right. And since we're here, let's make the equation. What lines do we have? What ordered pairs do we have? Well, we have a 0, 3. X is 0, y is 3. And any ones you want to use on the line. And here we have 1. That's pretty good. We have 1, 2, 3, 4, 5 for x, and negative 1 for y. So, what would the slope be? Okay, any pairs you want to use. Remember, the change of y over the change of x, rise over the run. So if we wanted to do 3 minus 1, that's the y, 3 minus 1, then we have to use 0, 0 minus 5. And what would we get? So 3 minus 1 will give us 4, and this will give us negative 5. So that's the slope. So now, and review that if you didn't understand that. Our slope, we have our slope and we have our y-intercept. There it is, right? So we can say now that the equation so far is y equals negative 4/5 x plus 3. There's the equation. Okay, great job.